All right, so we are solving trig equations today, and there's several different forms your answer can take. There are times when you can just answer in terms of a decimal from a graph. There are times where you will need exact answers, generally off the unit circle kind of thing, like pi over 3, pi over 7, pi over 7. Yeah, that's on the unit circle. 2 pi over 3, etc. The third option is that sometimes it will ask for all solutions, and then you're going to have to find an answer and tell me how often it would repeat. Because remember, the domain for all the trig functions is negative infinity to infinity. Okay, so there are infinite times that these solutions can show up. Before I get any further, I just want to talk about this for 1 second. When you saw this equation in the past, hopefully your teacher told you it was not a good idea to divide both sides by 2x because you would lose a solution. Okay, if you subtracted everything over to the same side, then you could factor out a 2 and an x, and you would get 2. Does 2 ever equal 0, guys? No, so if you had the 2x equals 0, you'd get x equals 0. If you had x minus 2 equals 0, you get x equals 2. So you had 2 solutions to this equation. If back here you had attempted, sorry, I don't have a cursor for some reason, to divide both sides by 2x, you would have had x equals 2 as your only solution. But the issue is you divided by this, so you had to say, like, x cannot equal 0 because you divided by it, but that's not true in the original. So you don't want to just divide through by any kind of a variable ever because you lose a possible solution. That's going to happen. We need to talk about that today. Students do that too often. Okay, give me 1 second to try to figure out why I don't have a cursor. There we go. All right. So this is the kind of equation we're going to have today. Cosine of x equals a half. We could graph the cosine graph, and we would see that it hit 1/2. He is at a training today, not here. It would hit 1/2 at pi over 3 and 5 pi over 3, and then it would repeat. Okay, if we did it on the graphing calculator, those would come out decimals. It would be better if we looked at our unit circle. Do you have your unit circle in front of you? That's one of the things you're supposed to take out. Where's the cosine 1/2? And then again at positive 1/2 for the cosine happens at pi over 3, and again at 5 pi over 3. Okay? And then if it asked for every time that happened, okay? So if it just asked for between 0 and 2 pi, down here, between 0 and 2 pi, you'd have those 2 solutions. But if it didn't specify a range of values and it wanted all solutions, okay? If it wanted all solutions, like negative infinity to infinity, you would have to say at pi over 3 and every multiple of 2 pi after that. Okay? Now, when I write this, I usually write pi over 3 plus or minus 2 pi n. They write pi over 3 plus 2n pi. I don't know why they put the n inside there. It doesn't really matter. You can multiply in any order. They don't put the minus because n stands for any integer. And an integer can be positive or negative, right? So you really don't need the plus or minus. I put plus or minus because it just reminds me in my head that I can go either way. And the same with the other one, 5 pi over 3 plus or minus 2 pi n. And again, they say where n is an integer. Cosine is weird. Cosine is the only one that this works for. Cosine and its reciprocal. If you chose that solution, and this solution, like we just did, okay, and say it repeats every 2 pi. But this solution right here is 2 pi away from this one. Does everybody see that? Now, what that means is I could not use this one, and instead I could use both of these and say they repeat every 2 pi. This would repeat here, this one would repeat here, and so on. The reason that that's kind of nice is because this is negative pi over 3, and this is positive pi over 3. So with cosine, you could write plus or minus pi over 3 plus or minus 2 pi n as a single solution. Hang on. Instead of these two solutions. Okay. That only works for cosine because it's the only one that has y-axis symmetry. So I will rarely do that because I think most of you would get confused and try to do that on everything. All right, so at the top of your notes today, it says to solve a trig equation, you may need to apply algebraic methods. They can include taking the square root of both sides, factoring, applying the zero product property. Guys, that's what says if you want to factor something, it's got to equal 0, right? Because I'm going to tell you, I get students doing this later. And they say, oh, well, let's see, we could say 2 sine equals 3 or sine minus 1 equals 3. Can you say two things multiply to make 3, so one of them has to equal 3? Is that possible? If two things multiply to make 0, it's true that one or the other of them has to be 0, right? Does everybody understand that concept? Okay. So we have to be careful that it equals 0 before we try doing the take your turn be an equal game, or with the zero product property. All right. You could need to do the quadratic formula. I promise I'm not going to put one on a test or quiz where you have to do the quadratic formula. You could need to rewrite as a single trig function, and we'll talk about some of those today. All right. So this one's worked out for you, so just watch for a second. If I had this, it already equals 0. What can I factor out of this side that those both have in common? This is a single multiplied quantity, and this. Yes. So I factor out a cosine x. What's left here is a tangent x. And what's left back here if I factor out a cosine? Minus 1. Okay. Then because it's equal to 0, either this equals 0 or this quantity equals 0. So I say the cosine equals 0 or the tangent of x minus 1 equals 0. If the cosine of x, well, I don't need to write it again, is equal to 0, between 0 and 2 pi, look at your unit circle sheet for me. This is very helpful. At the end, we have to know how are we answering. It wants only the answers between 0 and 2 pi. So I look at my unit circle and I say the cosine is 0 at pi over 2 and 3 pi over 2. Everybody good? Got to be looking at your unit circle. All right, this one is not your favorite. Where is the tangent 1? Now, please notice this is not the same thing as this. We talked about this before. This, when you write this notation, has a specific range of values, right? Was from negative pi over 2 to pi over 2. This equation, on the other hand, has infinite solutions, except they want us to use only the ones between 0 and 2 pi. All right, tangent is not on our unit circle. How are you going to find where the tangent is 1? What kind of an ordered pair would give you a tangent value of 1? Yes, when you put this y over this x, you would get 1, right? Where does that happen? Okay, it happens somewhere else on the unit circle. Yes, because if they're both negative, right, then it will be positive 1. And for tangent, you recall The period is just pi, so it's always straight across the circle. All right, so there's our 4 solutions. And, oh, they said this is a trick question. Okay, the reason it's a trick question is we came up with these 4 solutions, but we should be checking them. If we put back in our original equation, okay, pi over 4. Well, the tangent here would be 1, but what's the cosine at pi over 4? And square root 2 over 2. So 1 times the square root 2 minus square root 2 over 2 is going to be 0. That works. But if we go to pi over 2 and we put it in here, what's the tangent at pi over 2? Tangent at pi over 2 is, what's the ordered pair at pi over 2?
0.
Okay, so what's the tangent? 1 over 0 would be undefined. So this doesn't work because when you plug it back in, you get undefined. 3 pi over 2, the tangent also is undefined. So these two don't work and only these two count. I'm not going to be cruel and put that on a quiz like that because I would have got it wrong. All right, so you're supposed to always check your answers, and only 2 of those actually worked. That was hard. All right, when you solve for all solutions, if it says all, or if it says from negative infinity to infinity instead of 0 to 2 pi, then you have to say, I'm going to repeat this every how often. Now, this particular question, we were finding this part where the tangent is 1. How often does tangent repeat? Okay, so you could say at pi over 4 plus or minus pi n, or 5 pi over 4 plus or minus pi n. You actually don't need both of those because if you add pi to 5 pi, or I'm sorry, 1 pi over 4 plus pi, what would you get? 1 over 4 plus 1, which would be 4 over 4. You would get, okay, so this one, because you add 1 pi, gives you this one. You really don't need both of those. You could have one or the other. I don't care if you have both. All right, this is an ugly question. It says 4 sine squared. Okay, think this through with me. Don't just look at theirs. If you subtract so that it equals 0, you'll have 4 sine squared x minus 4 would be minus 3. Now, does that have anything I can factor out? No, and it's not difference of squares. So therefore, what they did was they moved the 3 back over there, and then I said it, I'm going to have to square root both sides. The square root of 4 sine squared would be square root of 4 is, square root of sine squared is. Okay, but anytime there was an x in there and you square root it, you need a plus or minus. Okay, whichever side you want to put the plus or minus on. Most of us put it on this side, but you could put it over here, doesn't matter. And then when you divide by 2, you get where is the sign, plus or minus square root of 3 over 2. Now look at your unit circle. Sign is in the y position. I need all 4 places, right, that it hits square root of 3 over 2 because it says plus or minus. So it happens here and here and here and here. Okay? Now, if we did not have a restriction, you could say that the answers were pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, if it just said 0 to 2 pi. If it said all solutions, it would be a little bit longer. You'd have to put some plus or minuses on the back. All right, this one does say all solutions. Again, you can just watch. If I add the sign over here, okay, so that they're all on one side, I have 2 sine x plus square root of 3 equals 0. Is everybody okay that that would become 2 sine x as we were adding, not multiplying? Okay, can I factor anything out? Do I need to factor anything out? It doesn't have a squared, right? So I can just subtract the square root of 3 and divide by 2 to isolate what we're looking for. So where does that happen? Look at your unit circle sheet for me. Sine is negative square root of 3 over 2 at 2 places. It is 4 pi over 3 and 5 pi over 3. Is that right? Okay. Now, am I done? I'm not done because it says all solutions. So I have to be thinking about the graph and thinking it's going to repeat. Basically, we're saying I could keep going around and find coterminal names for those places on my unit circle too. Okay. So I just put a plus or minus. How often does sine repeat? So we just put plus or minus 2 pi n, where n is any integer. And you don't have to write that. I'm okay if you don't. Any questions on that one? All right, here was their solution. Let's try this one together. Not complicated, right? Because it's already solved. Where's the cosine negative 1? Guys, this is one of the hardest sections. We usually end up requizzing and requizzing and requizzing on this because students don't get it. But we are so short on days this year that I need you to be ready to do this the first time. So be really good if you're awake, taking the notes, not on your phone, all that good stuff. Where is the cosine negative 1? Okay. It says all solutions. Am I done? Okay. Cosine repeats every 2 pi. So I'm going to need to say it repeats every 2 pi. Because I could say 1 pi, 3 pi, negative 1 pi. All of those would have the same cosine value of negative 1. Okay? All right. This one just reviews. Here's a quick example. On this question, I took out a sign from both of those. Then I said this could equal 0 or this could equal 0. So the sign would equal 1. Okay, there's 2 places on the unit circle where this is true, 2 places, no, just kidding, 1 place where this is true, where the sign is 1. But if you decided to somehow divide, if you moved the sine x over to the other side and divided by sine x, you would get sine x equals 1, and you would lose 2 of the 3 solutions here. So just don't ever divide by an x, and you'll be good. All right. What can I do to this question? You have this number 2. And again, it's all solutions. Sine cubed, I don't know what to do with that. But what can I do to both of these? Okay, if I take out a sine x, again, it doesn't go away. I'm just factoring it out. What will I have? I divided out a sine x. This is why we practiced with our trig identities. What is a sine cubed divided by a sine? Sine squared. And then there's a minus 4 back here. Yep. Yeah, this is times. Great question. This is times. Good question. Okay. What do you want to do with this, guys? You could do a square root. You just have to remember there's 2 solutions. But is this really factorable? Because it's like an x squared minus 4, right? So we have the sine of x. We have the sine minus 2 and the sine plus 2. Everybody okay? Now, this is not going to be as complicated as it looks. Because I say the sine could equal 0. If I set this equal to 0, I'll end up with the sine equals 2 when I add the 2 over to the other side. Can I skip that step? what would I have here if I set that equal to 0? Why did I just say this is going to be easier than we first talked about? Maybe. Where is the sign 2? Never. What is the set of values we have for the sign? Picture the graph. Sine graph can only go from what? -1 to 1. We get to throw this away. We get to throw this away. So where is the sign 0? Now look at your unit circle. The sign is 0, means the y value is 0 at pi, yes, 2 pi, 3 pi, 4 pi. Is the sign 0? Look at pi. What's the sign at 0, at pi? So it's at 1, 0 and at -1, 0, right? The sign value is, okay. So how do we want to write all solutions? Yeah, there's a whole bunch of ways you could write this. You could say at 0, and because it's a sign, it repeats every 2 pi. You could say at pi, and because it's a sign, it repeats every 2 pi. This is what most students would probably write. Do some of you see that there's a shorter way to write that? If you wrote it that way, yes, you'd have to write both of those. Anybody know a shorter way to say this? If here's the first solution, how far till you get to the next solution? Yeah, because we want to know where his 0 is, pi. The next solution after that is, okay, but how much further? So you really could say 0 plus or minus pi would hit all the solutions. No, you could just have plus or minus pi n. Yep. Because n could be 0. So this is a little bit shorter way to write it, but that only works sometimes, okay? So you're always allowed to just put down the solutions from your unit circle and then say it's going to repeat every 2 pi. You don't have to spend a whole bunch of time thinking about how to write it shorter. All right, what can we do on this one? Number 3, quick. Factor out a cosine. All of this is multiplied and all of this is multiplied. And remember, this is cosine of x and sine of x. It's not like you're multiplying by and x. Okay, this is all a function together. So if I took out the cosine of x, I would have what? And you certainly don't need all those extra parentheses, yes. I don't care. I'm not going to get picky. All right, now this times this is equal to 0. Sorry, I wrote that funny. It looks like it's elevated for some reason. It's not. So I have the cosine of x could equal 0, or the sine of x minus 3 could equal 0, which would mean the sine of x could equal 3. Okay, how often does the sine equal 3? Okay, so that's easy, no solution there. What am I looking for the cosine to equal 0? Means I need a 0 here or here, right? Where do those happen? Pi over 2 and 3 pi over 2. Now, because it says all solutions, we have to put plus or minus 2 pi n. Are there shorter ways to write that? Anybody think they know one? Because I'm okay with you just writing this. Nobody wants to worry about it? Nolan, can you think of one? How far from pi over 2 is it to 3 pi over 2, guys? They're straight across from each other, so you could write that. Okay. Actually, you could also put this out in front because another name for 3 pi over 2 is negative pi over 2. Okay, so there's all kinds of ways you could write it, but I'm fine with just the way we wrote it, the longer way. All right, what's somebody going to do here that we shouldn't do? I think I've talked about it several times. Divide by sine of x. What we need to do instead is subtract it over to the other side, then factor out the sine of x so we don't lose any solutions. What will it say after we factor out the sine of x? 2 sine squared of x minus 1. Okay? So we have the sine of x equals 0, or 2 sine squared of x minus 1 equals 0. Oh, this is kind of weird. Let's just worry about this one for a minute. Where's the sine 0? So you're looking for these ordered pairs because we want the sine to be 0. So it happens at 0 and pi, and it says all solutions, so we'd have to say plus or minus 2 pi n. Shorter ways to write that, yes, you could write 0 plus or minus pi n, or you could just write plus or minus pi n. All right, what are we going to do with this mess, though? Yeah, I don't think we can factor because of the 2, right? 2 doesn't factor, but we could say 2 sine squared of x equals 1. So sine squared of x equals 1/2. If we square root, what do we have to remember? Plus or minus. So if I square root both sides, I get the sine of x equals plus or minus the square root of 1/2. Anybody know what the square root of 1/2 is? Well, what's the square root of 1? And what do we have to do when it says 1 over square root of 2? So it becomes plus or minus square root of 2, or multiply by square root of 2 over square root of 2. So the square root of 1/2 is really the square root of 2 over 2. If you can kind of remember that, it'll save you some work later. But okay, so where is that happening that the sine is equal? This is not the answer, remember. Our answer is what x can be here or here. So tell me where the sine could be square root of 2 over 2. Now there's a lot of places. There's pi over 4, 3 pi over 4, 5 pi over 4, and now, because it said all solutions, those would all need a plus or minus 2 pi n. Is there a shorter way to write that? Yes, lots of shorter ways to write that. What do you notice about all 4 of those solutions when you look at your unit circle? Yeah, they're all straight across from each other, aren't they? So you could have said the first one plus or minus pi n, because you could go straight across, and then the second one plus or minus pi n straight across. There's even shorter ways to write it. How far is it, if we were thinking in our head degrees, how far is it from 45 to the next one? 90, right? It's 45, 135, 225. You're adding 90 every time. So you're really adding a pi over 2. So the very shortest way to write it would say I'm going to add pi over 2 repeatedly. Whoops, that's an n. But I'm fine with listing all 4 of them and putting plus or minus 2 pi n. This is not a contest. How short can you write it? Because I don't want you to get confused and write it wrong. What's different about the... Go ahead. Yes, thank you. We had in one unit circle, there were 6 different places that this would be true. Okay? We had these 2 and all 4 of these. Everybody get it all down? All right. What changes? It says on the interval 0 to 2 pi. You're going to get so excited on the quiz when you see one of these because it means there's a finite number of solutions. You don't ever need to put a plus or minus 2 pi n on, okay? It says only on that unit circle, how many places does this happen? Do you understand what I'm saying, guys? You don't have to worry about it. It's just one and done or two and done. What are we going to do here? Divide by 2 by an x. Great question. We're not dividing by an x. You can divide by a number. So where's the cosine 1/2? From 0 to 2 pi. Everybody see them? Good? So those are the two places, and because it doesn't say all solutions or negative infinity to infinity, we just get to be done. All right, what do you want to do with this mess? We need to isolate the sign of x. So I don't care what order we think about it, but what's 5 minus 7? Okay, and there's a 2 sine x. If we add that 2 over the other side, we'll have 2 sine x equals 2. Divide, and we get sine x is 1. Okay, you could have added the 7 and then subtracted the 5 and then divided by the 2. You still get the same thing. Where's the sine 1? How many places does that happen on the unit circle? Exactly one place. We're looking for this ordered pair, and it is at those are sweet, right? Don't have to remember any plus or minuses or try to think about how to write them any shorter. All right. One more. When they start throwing tangents in, that's when you really have to check your answers. Remember that weird one at the beginning where I had to check my answers and I didn't? So if I subtract the tangents over to this side, right now I have a 4 sine squared times a tangent. Then I'm going to subtract that other tangent over here so that it equals 0. Now what? Yep, factor out a tangent. What will I have left? Okay. Now, anybody notice anything about this? Are those all perfect squares? 4 sine squared and 1? So it could factor further. You could also just set it equal to 0 and then use a square root later, but you'd have to remember the plus or minus. So it actually factors 2 sine x minus 1 times what? Good job. Okay. Now it'd be really nice if we could throw away some of these, but I'm not so sure that we can. The tangent is 0. What would this all be if I set it equal to 0? 2 sine x minus 1 equals 0. 2 sine x equals 1. Sine x equals 1/2. Everybody good? Isolating the sign. Can I skip that step on this one? What would you get here? Negative 1/2. Okay. Now it says for all values only between 0 and 2 pi. Okay. So the tangent is 0. Where? Tangent is not on our unit circle. We got to think about it. But you need the y to be 0, right? So that you'd have 0 over 1 or 0 over negative 1 when you do tangent. So that happens at 0, pi. Now, it also happens at 2 pi, yes? We need to look really closely at this. Do we want to include the 2 pi answer?
Yeah.
Yeah, I don't know if you can see that, but this is a square bracket and this is a parenthesis, right?
Oh, yeah.
So are we supposed to include the 2 pi? No. All right, where's the sine 1/2? So we're looking for a 1/2 back here. And where is the sine negative 1/2? Okay. Now, according to us, there are a whole bunch of places where this is true, right? Now, the only thing that would make it not true is if we plugged something back in and it was undefined. We already know that the sine is defined at all these places. Yes? What's the sine at 0? And what is the sine at pi? Okay, and the sine at pi? I don't think so. They're both 0, right? Because it's a y value. If you go around 0 radians, the y value is 0.
Oh, okay. I thought you
Okay.
meant pi over.
Okay. All right. So the other question would be, if the sine is always defined at all those places, then we're good. Is the tangent defined at all those places? The tangent at 0 is 0. The tangent at pi is 0. Is there a tangent at all these other places? Yeah. It's crazy business, right? It's 1 over square root of 3 or square root of 3 over 3. But it's defined, so we don't have to throw any of these away. 6 solutions. That was lovely. All right. I'm going to do this one really fast. You'd have the cosine of x equals, if you added square root of 3 to the other side, you divide it by 2. Everybody okay? Can you tell me where it happens between 0 and 2 pi? It wasn't a plus or minus, right? It was just positive square root of 3 over 2 happened to these two places. Do I need any plus or minuses on my answer? Why not? Just 0 to 2 pi. All right. You can also do trig trades. You will have to sometimes do trig trades to solve. This is an ugly example, but you have it worked out, so just watch real quick. There is a tangent squared here, a secant squared here, and a tangent over here. So it's a hot mess. If you look at your list of what is secant squared equal to, though? 2 tan squared minus. What is secant squared equal to? Pythagorean identity on your peach sheet. Secant squared is equal to, okay, 1 plus tan squared. Then there was a plus 3, and on this side there was a 1 minus 2 tan. Okay, this is a hot mess, but at least are they all now in terms of the word tangent? Okay, so I got rid of this secant squared by replacing this. Now, I'm going to do some maneuvering here. Let's see if I distribute this negative. I'm going to subtract these over to the other side, add the 2 tan over to the other side. So now if I combine like terms, I have a -1, a plus 3, and a -1. What does that make? Positive 1, right? And I have a 2 tan squared. It's an x, sorry, not a theta, but... Oh, there was a minus tan squared right here. Combine those and what do we get? Just tangent squared, not 2. And then we have this guy, plus 2 tangent. Okay. That factors. It's like you have an n squared plus 2n plus 1. How would that factor? N plus 1, n plus 1. Everybody good? So this factors tangent of x plus 1 times tangent of x plus 1 equals 0. What's the only thing the tangent can equal? -1. Where is the tangent? -1. Tangent is so tricky because it's not on our unit circle. But what are we looking for where the tangent can equal -1? Where the y and x are the same but opposite signs, right? Where is it? Was this a 0 to 2 pi or all solutions? 0 to 2 pi. So we got two solutions. And they are right here on your paper, yes? Whoa! I don't know what I just did. Okay. This is an example that's really ugly that I can go through tomorrow. I'm going to do this question real quick. How would you do this? You could either subtract the 1 over and factor, or you could square root. Either way, you should get +1 or -1. Okay, how often does that happen? Where's the tangent? -1 or +1? Tangent is at pi over 4 is +1. It would be 5 pi over 4, right? This one is at 3 pi over 4 and 7 pi over 4. Okay, but this says all, so what do you have to do? You could put plus or minus 2 pi in, and I wouldn't count it wrong because you've really covered all 4 solutions. But it's tangent. What's the period for tangent? Pi. So actually, if you told me this one and pi, doesn't the other one happen straight across from it? And this one and straight across from it, you would hit all of them. If you put plus or minus pi in and listed all 4 of them, I wouldn't count it wrong. Pi over 2n, it would work, yes, because it's every 90. Yep, long as it makes sense. Okay. I didn't get through quite all of the examples. We can pick up a few more tomorrow, but this is the assignment. I cannot stress enough that you have got to practice this. There's 8 questions here. I want to know which 1 or 2 you couldn't figure out tonight when you come to class tomorrow. Please do the bookwork. Everybody should have a copy. You need an extra copy of the bookwork. I think they're still laying in the back.